Hello everyone and welcome to this video. Today I'm going to explain how you simplify radicals, and I'm going to tell you what a radical is and how you solve all of these problems I have listed here. Let's get down to it. A radical is basically an expression of the square root of a number, or the cube root of a number, or the fourth root of a number, whatever root you're trying to take of a number that will not give you a rational answer. Okay? So, for example, if I take the square root of 16, we all know that it's 4 times 4 that makes 16, so the square root of 16 is 4. So, I'm going to strike that out. We already answered that. Now, if you take the square root of 16, your answer is going to be 4. Because you got a rational number, an actual number that you know what it is, you say that's not a problem. So this is not a radical, because you can express it as an integer or a fraction or a decimal that is not irrational. So the key point is, when you take the square root of a number and the answer you get is a rational number, then that expression is not a radical. It's actually a perfect square. If a number is not a perfect square, that is, you can't find a number you multiply by itself to get that number, then anytime you take the square root of it, you'll always get a radical. So that expression is called a radical. For example, if you take the square root of 2, well, you can't think of any decimal that you know the exact quantity, the exact number of digits that will give you 2 when you multiply it by itself. Well, it could be 1.7. Well, 1.7 times 1.7 is not 2, is 1.89. Okay, so what if we add some digits? At the end of the day, you keep adding digits forever and ever. That's the meaning of a radical. It causes problems. So that's what I'm trying to explain to you. So this is a radical expression, and this is it. If we label this the top part of a radical sign, let's say you have a number here, this sign is called the radical sign. Okay? And this number here is called the radicand. So what's here is a radicand, and that's a radical. Okay, so if this is all you have, that's a radical sign. So this is a radical expression, or you just say it's a radical. Now, if you have an expression like this number x generally has to be a positive number. Okay, it has to be a positive number. It could be whole, it could be a decimal. As long as it's not a perfect square that you can find a straight answer to it, you say it's a radical. Okay, so one more example before I move on. If you take the square root of 0.25, the square root of 0.25, even though it looks as if it's not possible, it is possible, because it's basically 0.5, because 0.5 times 0.5 gives you 0.25. So you get that. So generally, if your calculator will give you continuous numbers that will never end, you know definitely it's a radical. But there are ways we don't throw things away just because they give us a problem, because they can help us solve other problems. So that's why radicals have to be simplified, so you find a way to get something good out of whatever looks like trouble for us. So let's move on to the next thing. I'm going to solve all of these and we'll see how that goes. So starting from the very first expression I have, I'm going to try and simplify this, rad 48. So, rad 48 is an irrational number because it's not a perfect square. You can't think of two numbers you multiply. So the numbers you will be thinking of right now are 1, because 1 times 1 gives you 1. So this is not a radical, okay? So you can think of numbers you will use. I'll just make a column here. So you're looking for numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, like that, because the square root of these numbers are whole numbers. So it's easy for you to establish simplified expressions using these numbers. So this is how you're going to solve this. Radical 48 will be, you have to look at these numbers here and see which of these numbers you can find in 48. The largest of them will be 16, because 48 is actually 16 times 3. So what you do to simplify this, say you want to make it look more reasonable, what you do is to rewrite this. This is going to be the square root of 16 times 3. Okay, so 16 times 3 is the same thing as 48. You haven't changed anything. So this expression is as if you're multiplying two radicals. So this will be the square root of 16 multiplied by the square root of 3, or you say rad. Okay, rad 16 multiplied by rad 3 is the same thing as this expression. Now you can simplify this, because we know the square root of 16 is 4, but this is a radical expression. You don't know the answer, so you just write it beside it. So the simplified form of rad 48 is 4 rad 3. Okay, so that's basically what that is. Let's move on to the next one. So I'm going to strike this out. Let's take the second example. So let's say our expression was rad 18. What you're looking for in this one is a number that is on this list that will divide 18, the biggest number, and you can see it's 9. So you rewrite this as the square root, or rad 9 times 2, because 9 times 2 is 18. You break this down, it gives you rad 9 times rad 2. Okay, we know this is a perfect square. The answer here will be 3. This you can't simplify, you write it beside it. So the simplified form of rad 18 is 3 rad 2. I'm sure you're beginning to look at those other expressions. Let's see for 10, rad 10. So this is done. Let's go to rad 10. For rad 10, what number here will divide 10? There's no number. So that's it. Rad 10 cannot be simplified further. You just let it be. Okay? So some expressions cannot be simplified further because those numbers are not multiples of perfect squares. So if you can't find a perfect square that will divide a rad or a radicand, it means you can't simplify the radical expression. If there is no perfect square that will divide the radicand, that's your final answer. You see here, because we know 9, which is a perfect square, will divide 18, that's why we were able to simplify this. Okay, let me take this one. I'll strike these two out. So let's go back to this and show you how you simplify that. So this is going to be 3 rad 45. So someone says simplify 3 rad 45. Sorry, I'm home because of COVID-19, so the vehicles are passing by and that's the sound you're hearing. But let's stay focused, okay? So at this point, this is 3 rad 45. Well, this looks as if it's already an answer, but no, because this rad can also be simplified. Think of one of these numbers that will divide 45. That's how you solve it, the fastest way. But you want to look for the biggest number. Well, the only expression that's here that will divide 45 is 9. So we have to rewrite this as this is equal to 3 multiplied by rad 9 times 5. So this gives you 3 multiplied by the root of 9 multiplied by the root of 5. And this is going to be 3 times the square root of 9 is 3, and this is going to be square root of 5. 3 times 3 is 9. This cannot be simplified. So that's your answer. So 3 rad 45 is the same thing as 9 rad 5. You got that? Let's go to the next one. So we've gotten rid of the simpler ones. Let's go to this one. 3 plus rad 18. Let's do that. So 3 plus rad 18 So we're going to 3 plus rad 18. Well, this is already fine. Let's try and simplify this. Remember when we simplified rad 18, it gave us 18 will be 9 times 2. That would give you root 9 times root 2, which is, so this is the same thing as saying 3 plus 9 times 2, which is equal to 3 plus rad 9 rad 2, which is equal to 3 plus 3 times rad 2. Well, you have 3 here and 3 here. There's nothing you can do. You can't add 3 to 3 rad 2, okay? So you leave your answer this way, or if you want to be fancy, you might choose to say it's the same thing as 3 into, if you factor, 1 plus rad 2, okay? 1 plus rad 2. Now rad 2 is a very common number, okay? Very common expression, because that's the diagonal of a unit square, okay? And there was actually a cult formed in Greece based on the square root of 2, because it was the first time plumbers discovered that they couldn't really find the exact diagonal of a square, of a 1 by 1 square, which would be this. It should be the square root of 2, but it was so irrational that they thought it was mysterious, okay? So, and this all came about from Pythagorean theorem. We can talk about that later. But this is a very common thing, because in trigonometry, this is what you're going to have. Okay? So you want to make sure you know some of these things. Just know them. Square root of 2, 1.4142. For those of you who need it. Square root of 3, 1.732. Okay? Square root of 5. You want to know those expressions. So let's go to this. So that's what happens here. I'm going to move on to the next one. When you add them together. So you have two radical expressions and you're supposed to add them. Let's go. So, two radical expressions. You have the square root of 12 plus the square root of 24. Well, we want to add them together. Well, you can't add because they don't look alike, unless you can find a way to make them look alike. Let's see. What is the largest perfect square that will divide 12? It must be 4. Okay, this number that will divide 12. So we can write this as square root of 4 times 3 plus, if you do the same thing for 24, it has to be 4 also. Only 4 will divide it. So it will be, what else? It's just 4. So 4 times 6 will divide that. That will be 4 multiplied by 6. And that gives us square root of 2, square root of 4, square root of 3, square root of 4, square root of 6. So this gives us 2 root 3 plus this gives us 2 root 6. Well, that's all. This and this don't look alike, so there's nothing you can do about it. So we're just going to let this be. So 2 root 3 plus 2 root 6, that's your final answer. Unless you want to factor. So it's going to be 2 root 3 plus root 6. Okay. That's that. Let's take this out. So this next one is root or rad 72 minus rad 50. What is the largest perfect square that will divide 72? Well, it will be 36. You see how I have a list? You want to have that list on your mind because it makes things faster. Okay? So I have 36. At your level, most of your numbers will not go beyond these perfect squares. Okay? Now, rad 72 will be the same thing as rad 36 times 2 minus, for this one it has to be 25. Rad 25 times 2. So this gives me rad 36, this would be rad 36, rad 2 minus rad 25, rad 2. So this gives me square root of 36 is 6, well, rad 2, and this would be the same thing as 5 rad 2. Now, this you can do something about because they are the same, okay? It's like saying 6x minus 5x. So your answer will be x. In this case, 6 rad 2 minus 5 rad 2, your answer is going to be rad 2. So the answer to this is rad 2. See, if you didn't know this concept, it would look tough for you to pick rad 2 if this is all you know. 72 is so far from 50 that there's no way you would think that the answer is just rad 2. That's why you need to learn these things, okay? So that's how you solve it. Simplify, simplify. If there's any way you can add or subtract, you do it. If the expressions are the same, and you have your answer. So your answer is 6 minus 5, which is 1. So it's 1 rad 2, but you don't write the 1. You just let it be like that. Let's move on to the next one. So for the next question, what we have is 4 root 7 minus 10 root 7 plus root 7. So 4 root 7 minus 10 root 7 plus root 7. So this is it. You just treat the rad 7 as if it were x. So you could say it in your mind, this is 4x minus 10x plus x. Okay? Because you can't simplify rad 7, it's even a prime number in itself. So this is going to be like 4 of this minus 10 of this plus 7 of this. So if you resolve these two, you're going to see that this will give you negative 6 rad 7 plus, this comes down here, rad 7. Now negative 6 rad 7 plus rad 7 is going to give you negative 5 rad 7. So that's your answer. Negative 5 rad 7 is the simplification of this. So let's strike this out. So we have this one, 2 divided by root 2. Now there's something important you have to know about radical expressions. You cannot have an irrational expression as a denominator. Let me give you something that's close to it, which is having 0. So I'm going to get rid of this. So if you have 2 divided by rad 2, it's as if you have something like 5 divided by 0. Okay, you can't get an exact answer to this because let's say you assume the answer is 0. What if I change this to 4? 4 over 0 is 0. Now, but you can't go back to the answer, okay? You can't go back to what's on top. If you can change any of these, if you can change 5 to whatever number and you always get 0, it doesn't make any sense. So dividing by 0 is not defined because there is no definite answer, okay? We also have the same problem with 2 divided by rad anything, okay? Once you have a radical in the denominator, you want to remove it. You don't want a radical in the denominator. And if that happens, you do what you call rationalization, which means you change this expression from being irrational into becoming rational, okay? So to rationalize an irrational quotient, all you have to do is get rid of the denominator by multiplying the denominator by itself. If you do that, you're going to get rid of this. Let's see. So what we have is you multiply this by rad 2 over rad 2. Multiplying this by itself, you can see this will divide out as 1, so you haven't changed anything. You're just trying to get rid of this here. So what this is going to become is 2 times rad 2 gives you 2 rad 2, and rad 2 times rad 2 gives you rad 4. Okay? Because you multiply the two numbers, that gives you 4. And this is 2 rad 2 divided by, what is the square root of 4? It's 2. So we can simplify and say our final answer will be, this will cancel this out, you have rad 2. If you make a clear observation, when you divide any number by its own radical, you'll always get just the radical as your answer. So if you put that in your mind, it helps you answer questions more quickly. So if you see a question like rad 5 and you put 5 over rad 5, your answer is rad 5, which makes a lot of sense because if you multiply this by this, you're going to end up with 5 equals square root of 25, which gives you 5. Okay, so dividing a number by its own radical gives you the radical. Okay, and that's what you call rationalization. You just rationalized it because it was irrational, but you want to make it rational. Now it's rational because it's this. the square root of 2, we know it is not a rational number, okay? But the process of you removing it from the denominator makes the fraction meaningful, because you can write root 2 as root 2 over 1. Assuming you did not know that root 2 or rad 2 was an irrational number. Okay, let's just go on. So you don't want to write a fraction with any radical in the denominator. So this is not acceptable. You have to rewrite it like this. This is the same thing as this. So we're going to try and see a way to rationalize this one also. Okay. So the next expression will be 4 divided by rad 3 minus 1. Okay, if this rad 3 was here alone, I will just tell you to multiply this by rad 3, rad 3. So we'll just do this. We'll say rad 3 over rad 3. That's what you would do if this was alone and this wasn't here. But because this is here, you cannot just go straight and say this is going to be rad 3, rad 3. What happens to the 1? It's going to create a problem for us. So in order to get rid of this, you look for the conjugate. Okay, the word is called conjugate of a surd. Okay, let me write it. The conjugate of this surd is, or what this radical expression is, the expression that looks like this but has a different sign in the middle. So rad 3 minus 1, the conjugate of it would be plus 1. That's all you need to do. So just change the sign in the middle, that's all. Once you do that, you'll be able to get rid of the radical sign in the denominator. So this expression here is called the conjugate. So the conjugate of rad 3 minus 1 is rad 3 plus 1. Okay, so let's do the multiplication. This you always do. Just change the sign in the middle. You have resolved the case. So with this, what we have will be 4 multiplied by rad 3 plus 1. Please remember the signs have to be different. What you have here has to have a different sign from what you have here. Okay, and this is going to be rad 3 minus 1, rad 3 plus 1. So if you multiply, you're going to get 4 rad 3 plus 4 divided by, now you multiply this, rad 3 times rad 3 is going to be 3. Remember that, we don't want to keep writing it. Rad 3 times rad 3 is going to be 3. Rad 3 times 1 is going to be plus rad 3. This times this gives you negative rad 3. And this times this gives you negative 1. So what you end up with will be 4 rad 3 plus 4 divided by, see this will take this out. What you have left will be 3 minus 1. And 3 minus 1 is 2. So you can actually divide each of these terms by 2 and you'll end up with 2 rad 3 plus 2. Okay, that's the final simplification of this expression. So this now is a rationalized radical quotient. Okay, you don't want this to be in the denominator. Okay, let's take the very final question and get this done with. So this one is just like the last one. So we find the conjugate of this. So the conjugate of this is just the same expression, but now this negative becomes positive. So it's going to be multiplied by, so we're multiplying by 2 plus rad 3 over 2 plus rad 3. And then we multiply out, we're going to have rad 2 plus 5 and 2 plus rad 3. Over 2 minus rad 3, 2 plus rad 3. Okay? And this is going to be, if you multiply this out, you're going to have rad 2 like this. So rad 2 times 2 will be 2 rad 2, 2 rad 2. And this times rad 3 will be rad 6. And then this multiplying this, like this, 5 times 2 gives you 10. And 5 times rad 3 gives you 5 rad 3. Then you go to this. This multiplied by this gives you 4. This times this gives you plus 2 rad 3. And this multiplying this will be minus 2 rad 3. And negative rad 3 times positive rad 3 gives you negative 3. Okay, so let's just simplify. That's the end of it. Well, what looks like what here? It doesn't look like we have anything that looks... I think there was a mistake on top here. It's 2 rad 5 plus 2 rad 3. There is no mistake. Okay, so we just write it out. So this is going to be 2 rad 2, 2 rad 2, plus rad 6, plus 5 rad 3, plus 10, all divided by, let's resolve this. This always disappears in the middle, and this is 4 minus 3. That gives you 1. Well, we don't need to write 1 here because it doesn't make any difference. That's it. Okay, so that's your answer. And this is how you simplify all radical expressions. In another video, I'm going to show you how to solve solve equations involving radicals. Okay, call them radical equations. Thank you for watching. If you learned anything in this video, please give it a thumbs up. You should subscribe if you haven't subscribed. And I hope you're staying safe during this period of the lockdown. Leave a comment in the comment section, or just leave a message if there's some topic you would like me to talk about. Thank you for watching once again. My name is Newton Okewoye. Never stop learning, because those who stop learning have stopped living. I'll see you in the next video. Bye-bye.